Welcome back to the Deep Dive. Today we're digging into something pretty major in the AI world. GPT-4 Turbo. It was announced late last year, right? At OpenAI's Dev Day.
That's right. And the key thing wasn't just, hey, here's a slightly better model. The narrative was really about optimization.
Optimization.
Yeah.
Making it work better, faster, cheaper for people actually using it day to day.
Exactly. So for you listening, our goal today is to, well, get past the hype. We want to lay out the actual technical changes, look at some early academic results on how it really performs, and touch on the challenges that, frankly, still exist.
Right, because the promise was basically GPT-4 power, but more efficient. Better price, speed, and scale for actually building things with it.
Think of it like this maybe. GPT-4 was this incredible, maybe slightly experimental high-performance car, super powerful, but maybe not practical for everyone.
Okay.
GPT-4 Turbo is like, they took that engine, refined it, made it more fuel efficient, faster off the line, and built it for, constant use, ready for the masses almost.
Okay, I like that analogy. So let's unpack that optimized engine. What are the big technical shifts from the standard GPT-4? I guess the context window is the headline grabber.
Oh, absolutely. We have to start there. The standard GPT-4 could handle, around 32,000 tokens? Which was already pretty impressive.
Yeah, that's like 50, 60 pages of text, already useful for some chunky documents.
Right. But Turbo quadrupled that. We're talking up to 128,000 tokens in one go.
Wow, 128K. What does that even mean in practical terms? Like a book?
Pretty much. You could feed it something the length of Moby Dick, or maybe a massive technical specification or a really long legal contract all at once without breaking it up.
Okay, there's a huge jump in scale. But why does that matter so much? For someone not analyzing entire novels, I mean.
Well, it changes the game for complex tasks. Imagine analyzing hundreds of pages of legal discovery or troubleshooting from a massive technical manual or even summarizing a whole field of research papers.
Ah, okay, so you don't lose a thread. The AI sees the whole picture at once.
Precisely. You avoid having to chop things up, feed them in pieces, maybe use external tools to manage the context. It keeps everything, in context. Reduces errors, speeds things up.
Makes sense. But usually, more power, more scale means way higher costs. That's always been the trade-off.
And that's the second big differentiator. Cost and efficiency. OpenAI actually reduced the price significantly.
Reduced it with 4 times the context. How?
Yeah, that's the surprising part. Input tokens became, I think, up to 3x cheaper and output tokens 2x cheaper than the standard GPT-4. Plus, it's faster, lower latency, higher throughput.
Okay, hold on. Cheaper, faster, and way bigger capacity. That sounds almost too good to be true. Are they sacrificing quality somehow? How'd they pull that off?
Well, that gets into the black box territory as specifics aren't published. But the educated guess in the research community involves techniques like quantization and parameter pruning.
Right, you mentioned those. Can you give us the quick, simple version? What are quantization and pruning?
Sure, think of it like compressing a giant super high-res photo. Pruning is like finding parts of the image data that aren't essential to the overall picture and removing them. Makes the file smaller.
Okay.
Quantization is like reducing the number of colors used. Instead of millions of shades, maybe you use thousands. The picture looks almost identical, but the file size is much smaller.
Got it. So they're making the model leaner and meaner, computationally speaking, without hopefully damaging its core intelligence too much.
That's the idea. Lighter, faster, cheaper to run, but still smart. And the third big piece is multimodality becoming standard.
Ah, the vision aspect.
Yeah. GPT-4 Turbo handles images natively. It can read text and images using OCR, understand the visual content, and combine that with text prompts. Oh, and its knowledge cutoff was updated, too, to April 2023, so a bit more up to date.
Okay, so massive context, way cheaper and faster, multimodal input, and updated knowledge. The specs sound amazing, but specs are one thing, performance is another. What are the early academic studies telling us? Does the quality actually hold up under scrutiny?
Right, this is crucial. And the picture emerging from benchmarks is, it's nuanced, it shines in some areas, but definitely still has limits. We looked at 3 studies that tested different things.
Okay, let's hear it. Where did you start?
First one was quite specific. Generating formal arguments or defeaters in something called assurance cases, basically testing structured logic.
Assurance cases.
Oh,
Sounds very technical, like for safety systems.
exactly. Highly structured, rule-based arguments. And the finding, GPT-4 Turbo actually did pretty well. It could generate these complex, logically structured counterarguments quite effectively.
Interesting. So it's good with rules and structure. What does that tell us?
It suggests it's very capable when you give it a clear template or format to follow. Think generating code, structured reports, things that need to adhere to specific rules. That's a big plus for practical applications.
Makes sense. Okay, what about something less rigid, like education? You mentioned a study using Bloom's taxonomy.
Yeah, this one looked at generating school-level questions about reading material. They mapped the questions to Bloom's levels, from basic recall up to complex analysis and evaluation.
How did you do there?
It was solid on the lower levels, generating questions that test basic knowledge, what year did X happen, or comprehension, explain why in your own words. It did that reasonably well.
Okay, the bread and butter of quizzes. But what about higher order thinking?
That's where it showed limitations. When asked to generate questions requiring real analysis, synthesis of different ideas, or evaluation like critique this argument or combine these theories, the quality was much more variable. Sometimes, okay, sometimes quite weak compared to a human teacher.
So good fact checker and summarizer, maybe, but not quite ready to lead a debate team.
Kind of. It highlights that gap between recalling information and truly reasoning with it, especially when things get complex or subjective. And that leads into the third study, biomedical text.
Okay, a specialized field. What were they testing?
They tested its ability to extract relationships between medical concepts in research papers, and crucially, they did it zero shot.
Zero shot, meaning no special training on medical data beforehand, just
Yeah.
using its general knowledge.
Exactly, testing its raw adaptability. And the results were actually quite impressive. GPT-4 Turbo performed competitively against models specifically fine-tuned just for that biomedical task.
Wow, that's quite versatile then.
It is, shows the power of the base model, but there was a key limitation.
Always a but. What was it?
Its performance dropped significantly when the text was messy, like if there were multiple overlapping relationships between terms or if the boundaries were ambiguous. When things got complex and unclear, it struggled to untangle them accurately.
Okay, so let's pull these threads together. Good with structure, okay with basic comprehension, surprisingly adaptable to new fields, but struggles with deep reasoning and ambiguity. What's the main takeaway for someone thinking of using it?
The big picture seems to be GPT-4 Turbo excels when the task is well-defined and structured. If you need structured output, like JSON, it's great. If you need to process vast amounts of information for summarization or basic extraction, fantastic.
Right.
But if the task requires deep analysis of conflicting information, handling subtle ambiguities, or true creative synthesis, that's where you still absolutely need human oversight and critical judgment. The performance isn't consistently reliable there.
That's a really important distinction. So let's talk applications. Given that huge context window and the efficiency gains, where are we likely to see GPT-4 Turbo making the biggest waves in the real world?
I think the most obvious one is large-scale summarization and analysis, things that were just too big or expensive before.
Like what specifically?
Think about a huge legal case with thousands of pages of documents, or analyzing years of customer feedback, or summarizing massive technical manuals. Before, you'd have to break it down, maybe lose context. Now, you can potentially feed it all in.
And ask specific questions across the entire data set in one go.
Exactly. Find all mentions of Project X across these 500 reports. Or compare Witness A's testimony with Witness B's across all depositions. That kind of cross-document synthesis becomes feasible.
That saves incredible amounts of time. And the lower cost must encourage more specialized tools, too.
Absolutely. That's fueling the rise of custom GPTs, people building tailored AI assistants for very specific niches. A legal research assistant trained on a particular firm's documents, maybe. Or a support bot for a complex software.
Or a tutor for a specific subject.
Precisely. The cost and scale make these hyper-specialized AIs much more viable for businesses and even individuals.
And we shouldn't forget the multimodal aspect, seeing images and text together.
Right. Analyzing reports with charts and graphs, understanding diagrams alongside instructions, maybe even uses in visual diagnostics, comparing medical images to text descriptions, and for coding.
Ah, yes, coding. Huge potential there, right?
Huge. Being able to see and understand code within the context of a massive existing project code base, that's powerful for generating new code, finding bugs, understanding complex systems.
With the big caveat, as always.
Human supervision is non-negotiable, especially in coding. It can generate plausible code that's subtly wrong or insecure. The human expert is still essential for validation.
Which brings us neatly to the limitations. Because as powerful as this is, it's not magic. What are the big roadblocks, the reasons we need to be cautious, especially in critical areas?
Well, the number one issue, the one that persists across all these models, is veracity, or lack thereof.
Hallucinations, making things up.
Exactly. It can generate answers that sound incredibly convincing but are just factually wrong, cite non-existent sources, or make logical leaps that aren't justified. In fields like medicine, law, finance, you simply cannot trust it blindly. Fact-checking and validation are absolutely essential.
Still requires that human in the loop for truth. What's next?
Bias. These models learn from the vast amounts of text data they're trained on, and that data, well, it reflects existing societal biases.
Gender, race, ideology, it's all baked into the web and books.
Right, and the model inherits that. So, without careful filtering and mitigation strategies, it can generate biased or unfair outputs, which is a huge problem for sensitive applications.
Then there's the black box problem we touched on earlier,
Transparency, or rather, the lack of it. We don't really know why it produces a specific answer. We can't easily trace its reasoning process.
which is a major hurdle for adoption in regulated industries, right? If you can't explain the AI's decision.
You can't really use it for high-stakes judgments. Imagine trying to justify a medical diagnosis or a legal ruling based on an AI you can't explain. It doesn't work for accountability.
Definitely a barrier. And lastly, even with the optimizations, there are still practical limits.
Yeah, two big ones: resource dependency and obsolescence. Even though it's cheaper, running those huge 128K context sessions still requires serious computing power. Not every organization can afford that at scale.
And obsolescence.
That knowledge cutoff. April 2023. The world moves fast. Anything newer than that, the model just doesn't know about natively. It needs constant feeding with up-to-date information through external systems, often called retrieval augmented generation, or RAE.
Which adds complexity and cost back into the equation.
Exactly. It's not a self-updating oracle.
Okay, so summing up the limitations. It can be confidently wrong, potentially biased, difficult to explain, resource-intensive, and quickly outdated. It's powerful, but needs careful handling.
That's the core trade-off right now. Huge leaps in capability, efficiency, and scale. But the fundamental challenges around truth, bias, transparency, and staying current, those remain significant hurdles.
So looking forward, where does the development need to go? What are the next big problems to solve?
Well, definitely tackling that knowledge cutoff issue, finding better ways for these models to continuously learn and update their knowledge without full retraining. Dynamic memory, perhaps?
Making them less reliant on static snapshots of the past.
Right. And explainability, or XAI. That's huge. We need better tools and techniques to understand how these models arrive at their conclusions. Auditability is key for trust.
And probable governance, right? Making sure these powerful tools aren't misused.
Absolutely. Robust regulation and safeguards against things like disinformation or malicious use are becoming increasingly critical as the models get more capable.
Okay, so that brings us to our final thought for you, the listener. We've seen that even GPT-4 Turbo, this incredibly optimized model, still struggles with higher-level reasoning and can confidently hallucinate. So the provocative question is, how much should we rely on purely AI systems versus hybrid systems?
Right. Systems that combine the AI's power with automated fact-checkers, real-time data feeds, and essential human experts in the loop. How do we design those hybrid systems effectively, especially when deploying AI in critical fields like science, medicine, or law, where the stakes are so high?
Something to think about. That's all for this deep dive. Thanks for joining us.